Hello dear learners, I welcome you all to the second module on basic electrical circuits of the SWAYAM MOOC on electricity and electrical wiring. In today's session, we will discuss about the fundamentals rule of electrical circuits, where we will focus on the voltage and current division rule, then Kirchhoff's law, then basic concept of DC and AC current generation. In the previous session, we learned about the interconnection of electrical elements in electrical circuits. The main purpose of electrical circuit is to transfer energy from source to load. Electrical circuits are the backbone of all the modern electronic devices. Now, to analyze how the electrical circuits function, it is essential to know and apply some fundamental rules that govern the behavior of electrical components like resistors, capacitors, inductors, and power sources. Now, the fundamental rules of electrical circuits help us to calculate current, voltage, and power in the circuits, and this ensures that they work safely and effectively. Now let us see the fundamental rules of electrical circuits. So in the introduction, why we use the electrical circuits? So the main purpose of electrical circuit is to transfer energy from the source to the load. And the electrical circuits are the backbone of all the modern electronic devices. And it is essential to know and apply some fundamental rules that is governed by the electrical components. The components that we have discussed, that is the passive and active components. Now this is a simple electrical circuit and which consists of a voltage source, a switch and a light bulb and the wires, connecting wires. And when the switch is on, that is it is closed, when the switch is closed, then the current flowing from the source through the switch and the lamp will turn on and the current return back to the source. So the current always flows when the switch is off, it flows like this, the light will on and again it is returned back to the source. So this is a simple electrical circuit, and thus the current has a complete path to flow. Hence, if a network contains at least one closed path, then it is called an electrical circuit. Now, to analyze how these electrical circuits function, it is essential to know and apply some fundamental rules. So, what are these rules? These rules that we are going to discuss, these rules will help us to calculate the current, voltage and power in any electrical circuit, and that works safely and efficiently. Now let us see the fundamental rules of electrical circuits. So now let us move the difference between the electrical network and electrical circuits. So in case of electrical network, it is the interconnection of various components such as battery, voltage source, current source, resistors, capacitors, inductors, etc. And electrical circuit is the electrical network that has a closed loop, having this gives a return path for the current. So in the difference, the electrical network can either be closed or open path. The switch in the circuit in an electrical network is maybe open or maybe closed. But in case of electrical circuit, it always have a closed path for current flow. And the second difference of electrical network is that it is not necessary to have both active and passive components in the electrical network. But in case of electrical circuit, it must have both the passive and active components. And the third difference is that in case of electrical network, all the networks are not circuit, but all the circuits are the electrical networks. So I think you have the clear about the idea of electrical network and electrical circuits. So let us move to the next topic, the voltage and current division rule. So first see the voltage division rule. Let us see the voltage division rule. So what is voltage division rule? It refers to the partition of a voltage among the components of the electrical circuit. Now the voltage division rule is applicable when all the resistors in a circuit carries the same current. That means what? They are connected in series combination. This voltage division rule is applicable when all the resistors in a circuit carry the same current, that we have already mentioned, that is all the connected in the series combinations. And it states that the voltage across each resistors in a series circuit is proportional to its resistance. And the second point, that is the principle of voltage division, is that the voltage drop across nth resistor. So in this circuit there are numbers of resistors. This is 1, 2, then dot 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 Rn. So Rn numbers of resistors are connected. So now what is the principle of voltage division connections is that the voltage drop across the nth resistor is equal to the ratio of Rn to the total equivalent resistance, that is Req, into multiply, that means this times the total voltage across all the n series resistors. So here Rn, from this definition, what is the voltage drop? That is, suppose Rn resistors voltage drop, that is we symbol as a Vn. So Vn equal to Rn divided by the sum of all the resistors multiplied by the total voltage. That is, if we apply the total voltage is V, then the voltage drop across Rn resistor is Vn equal to Rn divided by Req. Eq is the total equivalent resistance multiplied by the total voltage in the circuit. So let us see one example here. We have two resistors, that is R1 is 2 ohm, R2 is 3 ohm. Then the total voltage is given 10 volt. Then calculate the voltage drop across each resistor using the voltage division rule. So how we can calculate it? Now the voltage drop across R1. So what is the total resistance? RT, as they are connected in series. So R1 plus R2 equal to total voltage is 5 ohm. And Vt, that is total voltage, it is given as 10 volt. So what is the voltage drop? V1. So V1 is the voltage drop across R1. So it is 2, that is R1 divided by total voltage, total resistance, that is 5 into Vt. So it is 2 by 5. Now what is the voltage drop across R2? That is, if we suppose specify as V2, so V1 is 4 volt and V2 is the 6 volt. So using this formula we can calculate the voltage drop across each resistors or each element which are connected in series in the voltage division rule by applying the voltage division rule. Now let us see the current division rule. So in case of current division rule, when the current has to be divided across the resistors which are connected in parallel, this current division rule is applicable. Now the current division rule is used when the same voltage appears across all the resistors in a circuit, and the total current is shared by the resistors is inversely proportional to their resistances. So the principle of current division rule is that the current through the nth resistor, suppose it is symbolized as Rn, is equal to the inverse ratio of Rn to the total equivalent resistance, that is Req, times the total current through n parallel resistors. Clear? So you just read the definitions, read the principle again, and using this principle we can calculate the current across the Rn registers as this equation. So it is the ratio of inverse of Rn register divided by the equivalent registers multiplied by the total current. So let us see this figure where 3 registers are connected in parallel combinations and the total current is I, and first register's current flows is I1, I2, like this, In. So we can calculate the In, that is the current through the Rn registers, by using this formula. Now suppose we are consider one circuit. Here suppose voltage, this is plus minus. Now let us see in this circuit where registers are connected in parallel, what is the current in each registers. So using current division formula, this I1 is equal to, so I1 is across the R1, therefore 1 by R1 divided by, both are connected in parallel, so 1 by R1 plus 1 by R2. So I1 is equal to R2, that means the registers of the other nearest branch, that is R2 divided by total resistance, R1 plus R2. Now similarly, what is I2? I2 will be R1 divided by R1 plus R2 into IT. So this is the how we can calculate the current across the registers when they are connected in parallel using current division rule. Now let us see one example. Now if a parallel circuit with 3 registers where R1, R2 and R3 values are given, which are connected in parallel to a power supply 12 volt, then they calculate the current through each registers using the current division rule. Now let us first calculate the total resistance, that is 1 by RT is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the total resistance of the circuit. Now let us calculate what is total current. So IT will be V by R, so V is 12 volt. We have calculated the total current and the total resistance. Now we need to calculate the current across the R1. So I1 will be, I1 is equal to 1 by R1 divided by total resistance into total current. So this value, if we put the value, simply 1.2 ampere. Similarly, we calculate the I2 is equal to 0.6 ampere and I3 is equal to 0.4 ampere. So by this we can calculate the current across the registers. Now, so from this equation we can conclude that the current in any branch is equal to the ratio of the opposite branch resistance to the total resistance value, and it is multiplied by the total current in the circuit. So this is about for current division rule. Next we move the another law, that is the Kirchhoff's law. And the Kirchhoff's laws are fundamental principles which is used in the electrical circuit. It is used to analyze the current and voltage behavior. They consist of 2 laws. The Kirchhoff's laws has 2 types. One is Kirchhoff's current law and the other is Kirchhoff's voltage law. So first we see what is Kirchhoff's current law. So Kirchhoff's current law states that the sum of the currents entering any node or junction in a circuit is equal to the sum of the currents leaving that node. and the node is the node may be an interconnections of two or more branches. In the figure you see, let us consider the four conductors. These are the conductors which carries current I1, I2, I3 and I4, and it is considered that the current entering the point O, that is the O is the point where the four conductors are meets, and is positive. The current which enters the origin, that is O, are considered as a positive current, and the current which are leaving the point O, these are considered as a negative current. And by using the Kirchhoff's current law, we say that the current entering here in the figure, I1 is towards the O, so I1 is positive, and I2 is outwards the point O, so it is negative, minus I2, and I3 is the towards the O, so it is positive, then I4 is again negative. So if we sum all the currents, that is the which are entering and which are leaving, then we will get the total current is 0. And from this equation we can write this I1 plus I3 equal to I2 plus I4. That means what? The incoming current is equal to the outgoing current. Now let us see the Kirchhoff's voltage law. So what is the statement, and why? What is the Kirchhoff's voltage law? States that the algebraic sum of all the branches voltage around any closed path in a circuit, it is always 0 at all instant of time. So what it statement states? It states that in a closed circuit, the algebraic sum of the, or another way we can say, the products of the current and resistance, that means the voltage drop, of various branches is equal to the total electromotive force of the circuit. And this law is called as the Kirchhoff's voltage law. And when the current passes through the resistor, there is a loss of energy and therefore a voltage drop. So in any element, or it may be resistor, the current is always flows from the higher potential to the lower potential region. Now let us consider this circuit. In this circuit, three resistors R1, R2 and R3, these are connected, and two voltage source, two EMF, electromotive force, that is E1 and E2 are connected. Now if we apply the Kirchhoff's voltage law in the loop A, B, C and F, then according to the Kirchhoff's voltage law, we can calculate that E1, that is E1, it will be actually suffix E1 equal to I1 R1 plus R3 is one resistor. So here current flows is I1 plus I2. So multiplied by R3. And by simplifying this equation, we get that E1 equal to I1 R1 plus I1 R3 plus I2 R3. And ultimately we get that I1 into R1 plus R3 plus I2 into R3. So similarly, if we apply the KVL in the loop C, D, E, F, where the I2 current is flowing through R2 and I1 plus I2 is flowing through R1. So here EMF is E2. So we get that E2 equal to I2 into R2 plus I1 plus I2 into R3. By simplifying this, we get E2 equal to I1 R3 plus I2 into R2 plus R3. Now we get the E1 and E2 value we have. Now if we apply the KVL in the whole loop, that is A, B, C, D, E, F, applying KVL in the whole loop, we get that E1 minus E2 equal to I1 R1 minus I2 R2. So you please practice by yourself using different types of circuits, and you apply the KVL having the different branches and different values of resistors and voltage sources. So dear learner, having covered the voltage and current division rules as well as the Kirchhoff's law, it is the time to test your understanding with a few questions. I hope you have successfully answered these multiple choice questions. Now let us move to our next topic, that is DC and AC generation. So now let us discuss the concept of DC and AC generation. The direct current and alternating current are two types of electrical currents used in various applications. Now direct current generation. So direct current refers to the flow of electric charge in one direction only. That means the current remains constant over time and does not change direction. Now what is the basic concept of DC generation? The DC can be generated using the device called DC generators. A DC generator is a device that converts mechanical energy into direct current electrical energy. Now, how it is worked? A DC generator works on the principle of Faraday's law of electromagnetic induction. Whenever a conductor is moved in the magnetic field, an electromagnetic force is induced and the magnitude of the induced EMF is directly proportional to the rate of change of flux linkage. Now, this EMF causes a current flow if the conductor circuit is closed. In a DC generator, a commutator is used to ensure that the current flows in a single direction. Now let us quickly move to the construction of the DC generator. It consists of field system, armature core, armature winding, commutator and brushes. The field system consists of yoke, pole cores, pole shoes and field coils. It provides the necessary magnetic field for the operation of the generator. So next is armature. The armature is the rotating part of the DC generator. It contains the coil that cuts through the magnetic field, which induces a voltage. It is made of a cylindrical core made from laminated iron or steel sheets to reduce the losses of energy due to eddy currents. The next component is the commutator. The commutator is the key component in the DC generator. It converts alternating current induced in the armature winding into the direct current. It is cylindrical in shape and made of wedge-shaped copper segments, and these segments are insulated from each other, and each commutator segment is connected to armature conductors by means of a copper strip called riser. The next component is brushes. It provides a continuous electrical connections between the rotating commutator and the external circuit. They act as contact points to transfer the generated current. Now let us see the working principle of DC generator. A coil of wires rotates inside the magnetic field, and this rotation causes the magnetic flux through the coil to change, which induce a voltage. The commutator is used to reverse the direction of current in the coil at regular intervals that ensures the current always flows in the same direction in the external circuit. Now, what is the applications of DC? So DC is used in batteries, power supplies for electronics and electronic vehicles and devices requiring a constant voltage like laptops, phones and LED lightings. Now let us see what is the alternating current generation. Alternating current refers to the flow of electric charge that changes direction periodically. In AC, the current varies sinusoidally over time. Now, how is AC generated? AC is generated using an AC generator, also known as an alternator. An alternator works on the same principle of electromagnetic induction as a DC generator, but without a commutator. Instead, it uses slip rings to provide continuous contact with the rotating coil and generate an alternating current. Now, what is the working principle of AC generator? In an alternator, a coil of wire is rotated within the magnetic field, and this rotating changes the magnetic flux through the coil, which induces an electric current. The change in direction of the current occurs naturally as the coil rotates, producing alternating current. The frequency of the AC depends on the speed of the rotation of the coil. Now, where we use the AC? So, AC is used in power generation and distribution and in household appliances like refrigerators, air conditioners, lights, etc. So, what is the key difference between AC and DC generation? So, you please see in this table where we have featured the categories, and let's see the difference between the AC generation and the DC generation. So, the first feature is the direction of current. In DC generation, it is unidirectional, and in case of AC generation, it is bidirectional. That means it changes direction periodically. The next feature is the source. So, AC generation, the sources are batteries, DC generator, and in case of AC generation, the sources are AC generator. Now, the key component. In DC generation, the commutator is the key component, and in case of AC generation, it is used the slip rings. And we have already explained about the applications, that is DC is used in the electronics, batteries, low voltage systems, and whereas the AC is used in the power transmission, household appliances, industrial motors, etc. So, dear learner, we will explore about AC in more details in the upcoming sessions. So, here are some self-assessment questions based on the topic that we have just discussed, that is basic concepts of DC and AC generation. I hope you were able to answer these questions. I hope you enjoyed the video. See you soon with a new session. Thank you.